All right, we're going to solve problem number 2 on the example problems that I asked you to complete. This one here happens to be what we're going to call an explosion problem. An explosion simply says, let's read the problem. Two high school students here, two high schoolers are on stationary scooters, and number 1 gives number 2 a push. So let's just say they're right next to each other. They're on wheels. It doesn't matter. This is a diagram. That whatever this one experiences, this one's going to experience. And it simply says that one of them is going to travel in this direction, and the other is going to travel to the left direction. So here's what we know. We know it's an explosion collision, that the total momenta before the collision must equal the total momenta after the collision. So let's see, before, they're both, let's see, at rest. So there's no momentum prior, right? No, 0 kilogram meters per second. However, after, there's going to be 2 objects. So we're going to talk about the momentum of object 1 plus the momentum of object 2 must equal 0. So now let's apply the numbers. Let's look at this. So here's how it's written out. So 2 high schoolers are on stationary scooters, and student 1 gives a push to student 2. Student 1 has a mass of 85 kilograms. So let's start plugging in here. So student 1 has a mass of 85 kilograms. And student 2 has a mass of 68 kilograms. Student 1 travels to the right might mean something positive, with a velocity of 1.4 meters per second. What is the velocity of student 2? So we're solving the velocity of student 2. Let me scooch this over. So they have to equal 0. So I can do this a couple different ways. I can solve this right here, right now. I can simply say, let's see, this is traveling to the right, so I have to keep this positive. So I can subtract 68 kg times V2. Remember, that's what I'm solving for. That's what I'm solving for. So I can subtract both sides. So 0, I'm subtracting 68, so I get a negative 68 kilogram times V2. Remember, you can't have a negative mass, so this negative is really like saying a negative V2, right? 68 kilograms times a negative V2. In other words, this object is going to be traveling to the left, where this object was traveling to the right. Here's positive. We've defined positive and negative as being directional. So I can write this out. So I know that 85, let's see, 85 times 1.4 equals 119 kilogram meters per second, and that must equal 68 kilograms times a negative V2. I'm isolating this. I divide both sides by 68 kilograms, divide this by 68 kilograms. So I take 119 divided by 68, and I get a value of, so V2, negative V2 equals 1.75 meters per second. Let's see, well, this negative here, I can apply my negative to my velocity here, get rid of it here. V2, the velocity of student 2, is traveling to the left at 1.75 meters per second. So therefore, if I multiply these together, my momentum before must equal my momentum after. And I can always go back and check my work. That the momentum of 85 times 1.4, so if I plug this in, if I do the math, 85 times 1.4, this equals, oh, I had it right here, 119. That 119 kilogram meters per second, plus I can take 68 times 1.75. I know that's a negative 119 kilogram meters per second. Must equal my total momentum before the collision. Before, total momentum is 0 kilogram meters per second. 119 plus a negative 119, 0 equals 0. And I hope that makes sense.